Hello world! Today I'm going to give you a quick introduction about a really hot topic in computer science, which is algorithmic time complexity. At this moment you may be wondering, what is time complexity about, right? Well, let me tell you, time complexity, it's only a function that describes the amount of computer time it takes to run an algorithm. It's also commonly expressed using the big O notation. Well, now we have two things: the time complexity and the big O notation. So let's go to see what big O notation is, right? Big O notation, it's simply a mathematical notation for describing the worst case runtime of an algorithm. Also, it's the most common way to classify algorithms according to how the runtimes grow. For example, in this picture you can see some of the most common big O runtimes. To visualize it more clearly, let's go with some real-life example of two of these. Suppose we have a sorted array with integers numbers and we want to find a certain number in this array. There are basically two types of approaches. On one hand, we can perform a linear search in the array, which means going over each element until we find the number we are looking for. Of course, this will have a linear complexity, as in the worst case, we have to go over each element of the array to find the number we're looking for. Or on the other hand, we can perform a binary search that basically starts from the middle of the array and chops the array in half every iteration, leaving us with only a logarithmic complexity, which of course it is much faster than a linear complexity. Maybe at this moment you're wondering, why is this important to me? Or why is it relevant to me? Let me show you some numbers. If the input is not that big, for example, an array of only 10 elements, or in this case 10 numbers, you won't see many performance improvements. But as the inputs gets bigger and bigger, you will be able to see an extreme performance improvement. For example, in this case, we have an array of 1,000 elements, and the binary search do the same task than the linear search, but only in the 10% of the time it takes the linear search. So quite an amazing improvement, right? To conclude, there are 4 takeaways of this. First, remember the runtime is always expressed using the big O. Second, algorithm speed isn't measured in seconds, but in growth of the number of operations. Third, the big O measures how quickly the runtime of an algorithm increases as the size of the input increases. Remember, it's the size of the input, not time. Also, the logarithmic complexity is faster than the linear complexity, but you will only see relevant performance improvement when your input gets bigger and bigger. Finally, I also encourage you to try this linear versus binary search experiment by yourself and leave a comment below with your results.